All right, number 3, we've got a graph shown over an interval from -2 to 5, but the question involves a region that's even a little bit bigger than that. So one thing to kind of realize here is that if I take the entire integral from -6 to +5, that is the same thing as this missing piece, which I can't see, plus the piece that I can see. And the question is actually about this missing piece, right? So there's a section of the graph that I can't see. But knowing that the total integral is 7, I should be able to figure out the integral from -2 to 6 if I can figure out the integral of -2 to 5. Right? So if I set this up as kind of a final equation, this integral that I'm looking for, right, is really going to be the entire integral, which is 7, minus the integral from -2 to 5 of f of x. So the real problem here becomes kind of figuring out this integral. So let's look carefully at the graph here. So the region, the interval given is -2 to 5. So I'm basically figuring out all the area here. Trapped between, remember that area above the graph is a positive integral and area below is a negative integral. So these two sections are actually going to cancel each other out. These two sections are going to cancel each other out. So what I really have is just this region right here. And that's going to be, well, if you can't see that, sorry. These two cancel, so I have this, which is a trapezoid, and then this, which is related to a circle. So let's do the trapezoid first. That's going to be h, which is 1 over 2, times base 1, which is going to be 1, and base 2, which is going to be 3. So that ends up being 2. Right? This next little sliver here, I'm going to draw a little picture, is really a square with a circle inside of it. And I want to figure out one of these little slivers. So that's essentially what I'm looking at. This radius is 3, which means my square is 9, and I'm going to subtract a circle, which is, 9 by 9, which is 36. And my square is 9 pi. And that would be all 4 corners, but I really only want one of those. So that's going to end up being 9 minus 9/4 pi. And so when I add that to my trapezoid, I get the following. And so my final answer here is going to be 7 minus all of this stuff, and it's 11 minus 9 pi over 4. So you end up with a positive 9 pi over 4 and a negative 4. And so that ends up being my answer for part A. All right, part B is another integral. This time it wants us to evaluate this. It involves f prime. We've got a little fundamental theorem problem here. Let's start by breaking this apart. I'm going to also pull the 2 outside. So I'm going to take the twice the integral from 3 to 5 of f prime. We'll come back and do that in a second. Plus the integral from 3 to 5 of 4 dx. So this one I can use the fundamental theorem on. I get 2 times f, which is the antiderivative, evaluated at both 5 and 3. So that's going to be 2 times f of 5 minus 2 times f of 3. Each of those I can get from the graph. So f of 5 right there is 0. So this is 2 times 0 minus 2 times f of 3. If you look carefully and read the problem, f of 3 is given. You're not expected to figure that out. Equation of a circle, you probably could, but that would take a lot of time. It actually gives you that value. Okay? The other piece of my integral is just a rectangle, right? Y equals 4 from 3 to 5. If I drew that out, would simply be a rectangle that's 2 by 4, and so that's 8. You could also do that one using the fundamental theorem, but geometry is pretty easy there. So my final answer is going to be minus 6 plus 2 root 5 plus 8, and that's going to be 2 plus 2 root 5. Part C, this gives us an integral, asks us to find the absolute minimum value of g, where g is defined as an integral from -2 to x of f of t dt. We should also note that we know what g of, well, we're good, okay. So the first thing I want to do is find the derivative of g, and that's going to be f. That's our second fundamental theorem. Then I want to think about places where the derivative of g, which is the value of f, equals 0. Those are going to be critical numbers. So my critical numbers are x equals -1, x equals 1/2, and x equals 5. Of my possible absolute max mins, it's going to be these, as well as the endpoints, which are -2. And 5. 5's a repeat, so I don't have to do that again. And your best strategy in a problem like this is to simply find all of those values for g of x. Remember that g of x is an integral from -2 to x of f of t. All right, and so I want to use all these candidates, right? So -2, -1, 1/2, and 5. And from this list, I'm going to have my maximum. So let's start off. The integral from -2 to -2 is simply 0. The integral from -2 to 1 is going to be this little triangle, so that's going to be 1/2. Right? And the integral from -2 to + 1/2 is going to be this triangle, which is positive, this triangle, which is negative. Those are going to cancel each other out. And then this little mini triangle, which is -1/4. So that's -1/4. And then 5, we actually figured out in part A, right? The integral from -2 all the way to 5 was that 11 minus 9 pi over 4 number. We did that in part A. So then I have to figure out of these which is the absolute maximum. All right, I can rule out this one. This I have to think about a little bit, but knowing that 9 pi is about 27-ish, divide that by 4, you get about 7-ish. This is going to be around 4. We definitely know this is bigger than either 0 or 1/2. Don't even need my calculator for that. So 11 minus 9 pi over 4 is going to be your answer. And your justification for this problem is really this analysis here. If you list all the candidates and you find the values at each one of them, you can conclude that this is my absolute max value. Doesn't ask for the min, but the min would be this -1/4. If you wanted to, you could maybe make a geometric argument here that this function g is actually accumulating area starting at -2. So you accumulate some positive area, then you go back down, then you continue to go down, and then all of this is up. So if you said something like this area outweighs any negative area, making 5 the maximum, that might be a good argument, but you still have to give the y value anyway. So 11 minus 9 pi over 4 is our answer. All right, part D is a limit problem. A lot of times we need L'Hopital's rule to kind of trick you with this one. It's just straight, can you evaluate all of these things at 1? So 10 to the first is kind of easy. 3 times the derivative at 1. If I go up here and look at the slope of f at 1, that's going to be a slope of 2. F of 1 is simply 1. And then arctangent of 1, without your calculator, you should know is pi over 4. Putting all that together, I get 10 minus 6 over 1 minus pi over 4, which is 4 over 1 minus pi over 4. You can do some more simplifying, but this is an acceptable and perfectly fine answer.